right now we started recording. So and if you miss some part of the class, you can access, I don't always record the things where I'm just talking some thing that's not so important, but for the actual coursework, I will be recording. Okay, so here I'm going to be putting on 2 problems on the board. And I would like you to work on these 2 problems and see if you remember how to solve these equations. So here's the first one. The first one is 2x plus 7 equals -2, parentheses, x minus 3 plus 5. The second equation I'm going to put over here, a little bit similar but a little harder, is 3 parentheses 2x minus 1 minus parentheses 4x plus 3 equals 5x minus parentheses 7x plus 1. Okay, I'm going to give you a few minutes to work on these 2 problems and see if you could come up with the solutions. If you want, you can then put the solutions on the chat.
Professor,
Yeah,
for the second equation, is that 7x minus 2? I meant minus 1.
plus 1. It's 7x plus 1. Okay, I see that a lot of people have finished example number 1. So let's review example number 1. And then I'll give you a little more time to do example number 2. Okay, so let's just remember, what is the point of solving an equation? When we have an equation, we have a statement about numbers. And one of the numbers, we don't know what it is. That's why we're calling it x. X is some unknown number. When we're solving the equation, what we're trying to do is make sure that we find a number that when we replace x by that number, it'll make what we're saying a true statement. It will make the two sides of this equation equal, meaning they're going to be exactly the same number. Okay, and the first step in solving the equation is, if there are any parentheses, to remove the parentheses. And so in this side, there are no parentheses, so we just leave this the 2x plus 7. On the other side, there's a negative 2 in front of that parenthesis, so we use our distributive property to remove that parenthesis, and we get negative 2x, and negative 2 times negative 3 is positive 6. It's called distributive because we have to multiply both numbers inside the parentheses by what's outside, and then we just bring the 5 down. Our next step is to get the two sides of the equation as simple as they possibly can. In other words, if there are any like terms, combine those like terms. Well, over here, there are no like terms, so I just bring down the 2x plus 7. Over here, we have a 6 and a 5 that can be combined. They're like terms because they don't have any x's in it. So I leave this negative 2x, and the 6 and the 5 give me plus 11. So now we've simplified things, so we have 2 terms on one side and 2 terms on the other side. I'm sorry, I was trying to read it. Somebody sent me a check. I now want to make sure that I get all the x's to one side and all the numbers to the other side. And I make it a policy that I will always bring the x's to the left side and the numbers to the right side. Now, when you're solving an equation, that really is not necessary. You could end up with all the x's on the right and all the numbers on the left. But when it comes to our next topic, which is going to be inequalities, it's going to be extremely important to make sure that we get all the x's on the left and all the numbers on the right. So I always do it. So I'm going to want to get rid of this negative 2x, which I'm going to do by adding 2x. I always do the opposite operation, the opposite sign. So here I get the 2x plus the 2x, which gives me 4x plus 7. Here the negative 2x and the positive 2x cancel, and this gives me 11. I then want to get this 7 to the other side. So since it's a plus 7, I'm going to do minus 7 from both sides. That will give me 4x equals 4. And when I divide it by 4, I get x equals 1, which I think most people did give me that answer. X equals 1 is the correct answer. What this is saying is when I solve, I can even just say, instead of saying x equals 1, I could just say the answer is 1. Obviously, that means that the x is equal to 1. That when I replace the x with 1, I will make the original statement a true statement. That's what solving an equation is. Okay, I'm going to give you a couple more minutes to try that one if you didn't finish it, and then we'll do that one together as well. It doesn't have to be in a private chat. No, it could be in the regular chat. We can just, if you want to send it to me privately, also, it doesn't make a difference. But other people might be interested in seeing the answer as well. So it doesn't matter if you send it as a private chat or as a regular chat. Does anybody want more time to work on that problem? Okay, since nobody seems to indicate that they need more time, let's work on this together. Again, the process is going to be the same. We're going to remove the parentheses. We're going to get all the x's to the left side, all the numbers to the right side, and then we're going to divide by the coefficient of the x. That's the basic thing. What's basically different about this problem than that one is the fact that we have two places where we have parentheses and there's no number in front of the parentheses. Well, if there's no number in front of it, it's as if there's a 1. Anytime, it's just like when you say x, you mean 1x. When you have a parentheses with no number in front of it, it's as if there's a 1 in front of that parentheses. So when we go to remove the parentheses, again, we're going to use our distributive property. And the first thing we're going to do in the first parentheses is multiply everything by 3. So this is going to give me 6x minus 3. The second parentheses, which just has the negative in front of it, I'm going to look at it as if it's a -1 and multiply everything by -1. So -1 times 4x is -4x. And -1 times 3 is -3. Essentially, what it's done is changed the signs of everything in that parentheses. The 5x, we're just going to bring down. And again, in this parentheses, we're going to multiply everything by -1. So it's going to be -7x. And this is a +1, so -1 times +1 is -1. So we've removed all our parentheses. Now we're going to combine our like terms. So first we combine the x terms. This is a 6x and a -4x, which will give me 2x. And this is -3 and -3. When I combine a -3 and a -3, that gives me -6. Over here, I have a 5x minus a 7x, which is -2x, and a -1. Okay, things look a lot simpler now. Again, I'm going to bring the x's to the left side, so I'm going to add 2x to both sides. This will give me 4x minus 6 equals, now this cancels out -1. So I'm going to add 6 to both sides, so I'll have no numbers left on this side. I'm getting rid of that -6, which gives me 4x equals -1 plus 6, which is 5. And my final step is to divide everything by 4, so that my final answer comes out to be x equals 5/4. If you want it, you could leave your answer like this. This is a perfectly good answer. Usually when we have answers with fractions, we leave them as a fraction and we leave them as what's called an improper fraction. We don't bother simplifying it, but if you would put it into your calculator, if you would have gotten 1.25, and that's a perfectly good answer as well. This is one step more. It's not necessary to do this extra step, but either of these answers is the correct answer. Are there any questions about either of these? Okay. Sometimes in our equations, we have fractions, and sometimes we have decimals. Now, today I'm not going to be talking about fractions. I want people to have their calculators before they have to do fractions. And actually, we're going to have a whole section that'll deal with fractions. So I'm going to put off dealing with fractions in equations, but I am going to do a problem that involves having decimals in it. Again, if you have a calculator, try doing your calculations with your calculator. You'll see how much easier and more accurately you do work when you have a calculator. Okay, so here's a problem for you to try. (0.06x minus 0.05 times parentheses 9,000 plus x equals 470. And I'm going to give you a few minutes to try that problem, see if you can come across with an answer for that. Okay, I see people are beginning to have answers, so let's try and do this together. The answers I saw, I think were correct. Let's go through this together. And Since I have a calculator, I'm going to be using my calculator. Just like we did before, we want to remove the parentheses. So I'm going to leave this as 0.06x. And then I'm going to multiply everything over here by negative 0.05. And when I multiply the 0.05 times 9,000, my calculator gave me 450. So that's negative 450. Then I have negative 0.05 times x, which is negative 0.05x, and that equals 470. Okay, now we want to combine the like terms. We're doing exactly what we did before. And the like terms are the 0.06x and the negative 0.05x. And when I do 0.06 minus 0.05, I get 0.01. So it's 0.01x minus 450 equaling 470. And of course, now I want to get the x's alone, so I'm going to add 450 to both sides. So I get 0.01x equals 920, because 470 plus 450 gave me 920. And now I divide both sides by the coefficient of the x, which is 0.01. And either you could do this in your head or you can do it on, that's why I like my calculator. When I do 920 divide by 0.01, it gives me 92,000. And if you notice, I didn't have to, it's easy to make a mistake on the decimal. If you use your calculator, you're much less likely to make an error. Okay, I see everybody who gave me the answers did come up with 92,000. Great. So that's how you do it. Again, the only thing that made this more difficult than the ones before is the fact that you have to be careful with your decimals. Again, if you have a calculator, you're not going to have any problem with your decimals, you just stick them in. So again, as I said, I'm not doing examples that have fractions right now. We're leaving the fractions for another session. I want to go on to, since I really feel that you know how to solve basic equations, go on to the next topic, which is solving of inequalities. Okay, now, just like an equation tells you two things are equal, an inequality tells you two things that are not equal. But when two things are not equal, there are more than one way they could be not equal. Two things are equal, they have to be identical. But if it's not, they're not equal, we're talking about numbers, one could be greater, one could be smaller. So here are the four different options of the way we can indicate things that are not equal. We could say something like this: x is greater than 5. In other words, we can have, if we have two numbers, one could be bigger, one could be smaller. X is greater than 5. Notice the opening is always to the larger number. Or we could have something very similar. We could say something like x is greater than or equal to 5. To say x is greater than 5 means we're talking about all the numbers that are bigger than 5, like 5.1, 2 million, a billion. To say x is greater than or equal to 5 means not only are we talking about all the numbers that are bigger than 5, we are including 5 as well. I'm going to show you how this looks on a number line in a minute. The other two expressions of inequality have to do with less than. We could have something, let's use a different number. We could have something like x is less than -2. So we're talking about x being smaller than -2. Or we could have something like x is less than or equal to 3. The difference between a less than and a less than or equal to is when we talk about x being less than or equal to 3, we're talking about all the numbers that could be 3, or less. Whereas if I say x is less than -2, I don't include -2. -2 is not included. X is less than 2 means it has to be smaller than -2. Now, the difference between inequalities and equations is that usually with an equation, we have one answer. Sometimes we even have equations that have two answers, but it's a very limited number of answers. When it comes to inequalities, there are a whole bunch of answers that can work. So, in other words, if I say x is greater than 5, I can mean 6, I can mean a billion, I can mean 5.11. There are an infinite number of answers that they can be. So very often we express these inequalities by graphing them on a number line. Now, what does a number line look like? It's a horizontal line, though you could have a number line that's vertical as well, but usually when we're dealing with these type of number lines, we have a line that goes straight across. We pick one value to be the 0. When we go to the right, we number it by positive numbers: 1, 2, 3, 4, 5, 6, 7, on and on and on, all the way to what we call infinity, this sideways 8, which means just going on without any stop. When we go to the left, we use the negative numbers. And again, these go on and on and on to the left as far as what we call negative infinity. Now, neither infinity nor negative infinity are specific numbers. They're just an indication that it's all the way as far as you could go, it's even further. Okay, that's what a number line looks like. How do we picture x greater than 5? How do we graph it? So we start at the 5, which is right here, and we make an open circle. And from that circle, we make an arrow going to the right. Notice how this looks like an arrowhead? It's pointing to the right. Again, I have to have the x first. X greater than 5 means x is to the right. It means it's to the right of 5. So we make our arrow going to the right. Notice at the 5, I made an open circle. That's to indicate that the 5 is not included. It means starting just beyond the 5. On the next one, where we would have x is greater than or equal to 5, we again would start at 5, but we would make it an filled in or closed circle, because x being greater than or equal to 5 means it's 5 or more. Again, that arrow looks like it's pointing to the right, so we make an arrow from here going to the right. So the difference between this one and this one is simply, do we fill in the circle or do we leave the circle open? And that depends on whether you have this additional little line there. When you have that additional little line, you've got to have the filled in circle. You have to include the 5. What about this one? Here's x less than -2. So I have to start at the -2, which is to the left of the 0. Since it says x is less than -2, when there's no equal sign, it's an open circle. And in this case, this looks like it's pointing to the left. We make an arrow pointing to the left. In other words, it's starting all the way at negative infinity and going until -2. When we talk about these sections or intervals on the line, we're always starting at the left and moving to the right. In this case, this interval starts all the way to the left at negative infinity and continues until -2, but not including the -2. This last one, where it says x is less than or equal to 3, in that case, I start at the 3. I would make a filled in circle at 3. And again, an arrow pointing to the left, because we're talking about the numbers that are less than 3, but we filled in the circle to include the 3 as well. So these are the 4 different types of inequalities we might encounter. And I think it's obvious that you can't just say the number. You can't just say -2. You have to indicate, is it x less than -2? Is it x greater than -2? Is it x less than or equal to -2? Not only must you name the number, you must name the sign, because it could be, in an inequality, could be any one of 4 signs. Okay, that being the case, I'm going to show you how to solve an inequality and how we go about graphing the solution of the inequality. Okay, any questions before I go on? Okay, so let me put a problem on the board. Let's say I gave you this problem. (7x minus 3 is greater than 18). Here is an inequality that we want to solve. Now, just like when we solve an equation, we want to get the x alone. The same thing is going to be with an inequality. In other words, the steps of solving an inequality are almost identical to the steps of solving an equation. So I want to make sure that all the x's are on the left side, and I always want to end up with x's on the left side, and all the numbers on the other side. So I'm going to get this -3, and I'm going to add 3 to both sides, so that I end up with 7x is greater than 21. In other words, we're following the exact same steps that we used in solving an equation. Once we have the x's alone on the left side and the numbers on the right side, we then take the coefficient of the x and divide both sides by it, just like we did with an equation. I'm going to divide both sides by 7. Now, there's one thing you have to be very careful about, and that's when you divide by the coefficient. If the number you're dividing by is positive, as in this case, you leave the inequality the same way, and you get x greater than 3. If you are dividing by a negative number, and we'll be doing a couple of those soon, then you have to be careful, because anytime you have an inequality and you divide by a negative number, you are switching the direction of the inequality. You're switching the sense of the inequality. So here we didn't have to switch the sense of the inequality because we divided by a positive number. Now here's a solution. X is greater than 3. Once you have x alone, then you have solved the inequality. Now you can't just say 3 is the answer to the inequality. because you have to say not only what the number is, you have to say, is it greater, is it equal, whatever. So here we have a solution is x is greater than 3, which on the number line would have looked like this. We go to 3. It's just a greater than, not a greater than or equal to. So that's an open circle. It doesn't include the 3. And the arrow is pointing to the right. So here's our solution as an inequality. Here's our solution as on the number line. Okay, let's do another one. Four x plus 5 is greater than or equal to 7x plus 20. I'm going to give you a couple of minutes to try this one out on your own. Okay, see a few people have the answer, and I do see some correct answers, so that is a good sign. Let's work on this together. Okay, we have the 4x plus 5 is greater than or equal to 7x plus 20. The first thing I want to do is get those x's to the left side. So I'm going to subtract 7x from both sides. As I said, when in an equality, it's very important that you always be left with the x's on the left side. So we have 4x and negative 7x, which gives us a negative 3x plus 5 is greater than or equal to 20. The next thing I have to do is get rid of this 5, so I'm going to minus 5 from both sides. That'll give me negative 3x is greater than or equal to 15. Notice I kept the direction of the inequality the same throughout. But now on my last step, I have to divide by the coefficient of the x, which is -3. So I'm dividing both sides by -3. But remember what I said, when you're dividing by a negative number, you've got to switch the direction of your inequality. So this will become x less than or equal to, well, 15 divided by -3 is -5. And this is your solution as an inequality. If we want to do the solution of that on the number line, it will look like this. Okay. Here's my number line. -1, -2, -3, -4, -5 is right here. It says x is less than or equal to -5, which means I put a filled in circle at -5, and my arrow has to go to the left. And that would be the number line solution of that inequality. Okay, don't forget that when you are dividing by a negative number, you must switch the direction of the inequality. I just want to mention one other thing today, and that has to do with something that's called interval notation. It's a third way of indicating a solution to an inequality. As we said, one way is just to write the inequality. X greater than, less than, whatever it is, the number. The other way is to draw it on the number line. This third way is what we call interval notation. And if you notice, the number line really shows you very clearly what's happening. Remember, in an equation, you're getting one answer. Maybe sometimes you get two answers, but that's it. You're very limited. But with an inequality, you have a whole bunch of answers. You have an infinite number of answers. So you have to show more than just a number. Again, we can show it by showing the number line. Notice this is saying if you started all the way out at -infinity and went all the way till -5, including -5, any one of those numbers would be a solution to the inequality. What isn't a solution? Anything from that's to the right of -5. In other words, 0 doesn't work, because if I put in 0 for x, I'd get 5 greater than or equal to 20. That's not true. So any number less than 5 works. Any number greater than -5 doesn't work. So what's important here? When we're looking at the number line, what's important is where does the number line start and where does it end? Now, if you look at this, since this arrow is pointing all the way to the left, it means that it's going until -infinity. So actually, and when we talk about intervals, we're always talking as we go from left to right. Since our number line increases as we go from left to right, our intervals always have to be mentioned starting at the left and going to the right. There are two numbers involved here. There's the number at the left end of the interval, and there's a number at the right end of the interval. Now, at the left end of this interval is the number -infinity. You remember, it's just indicating, it's not a specific number, but it's written as a number. The number that's at the end of the interval at the right end is the number -5. So we put a comment, -5. So, and when you're doing interval and notation, you only need to write two numbers. The starting number of the interval, all the way to the left, and the ending number of the interval, which is all the way to the right. Then you have to enclose these things in either parentheses or brackets. Now, so either we're going to use parentheses or we're going to use brackets. Those are the square brackets. Where you have infinity or negative infinity, you always put a parenthesis. Where you have an actual number, whether you use a parentheses or brackets depend on whether the number is included. If it's an open circle, you use a parentheses. If it's a closed circle, you use a bracket. So for this interval, the interval is from -infinity to -5. Starting at -5, going till -5, starting at -infinity, going until -5, including -5. In other words, -5 is filled in. So the interval notation very clearly does what the number line does, except it doesn't take up as much space. Will there ever be a time we get something that inconclusive, like something? I don't think you have to worry about that. We'll be able to graph something. You're not Maya, it's only a question. We're doing the simpler ones. We're not getting into this is college calculus yet. So don't worry about things that can't work. Okay? All right. Now, just to show you how this interval notation works with other types of situations, let's just write a few inequalities. What if I gave you something like x is greater than -2? Let's see how that would look on the number line and how it would look on an interval notation. So if we have x is greater than -2, we go to our -2 on our number line, which is right here. It says x is greater than -2. It's an open circle because there's no equal sign. The -2 is not included. And it's greater, which means it's going to the right. This is what the interval looks like on the number line. What does it look like in interval notation? Okay, let's look at our interval. Where's the start of the interval? Remember, this interval always starts on the left and continues to the right. So the starting point on this interval is the -2, because that's the one that's most to the left. That's the start. The end of the interval, well, it's going on to all the way to infinity. So here's my starting number, here's my ending number, again, with a parenthesis, a comma in between. Since the -2 is not included, because it's an open circle, we use a parenthesis at the -2. And we use a parenthesis at the infinity because we always use a parenthesis at infinity. Do you see again how much less space is taken by this, but it's really telling you the same thing as the number line because it's telling you where to start your arrow and where to end your arrow. Okay. We have a few more minutes, so let me give you a problem to try and see if you could do it using and putting your answer in interval notation. -2 is less than or equal to 7 minus 3x. And this is a little bit of a tricky one because I have the x on the wrong side. So make sure you get it in the right. I'm going to give you a few minutes. Okay, yes, Adina, let me answer your question. When you have a less than or equal to or a greater than or equal to, yes, you have to use a bracket instead of a parentheses at the number. At the infinity sign, you always put a parentheses, but at the where you have a filled in circle, you have to use a bracket, not a parentheses. Does that answer your question? Good. Don't forget, you could ask me, you don't have to only ask me questions on the chat. If you find it more efficient to ask me questions by not having to type it, but just speaking, please do. I know I'm not fast at typing, so I always speak. Does anybody want more time? Okay. Okay, can you, Brandon, can you put that in interval notation? Actually, doing interval notation on your keyboard is not so hard because there is you can type in either parentheses or a brackets. It's, the infinity sign is, you could just write the word infinity. Okay, let's do this together. I really want to get all the x's on the left side, all the numbers on the right side. Now, I happen to have an x only on the right side. So the first thing I'm going to do is I'm going to add 3x to both sides. Even though it seems not the most efficient way to do it, it'll get me to what I want. So I'll get 3x minus 2 on the left, less than or equal to 7 on the right. I then will add 2 to both sides, which will give me that 3x is less than or equal to 9. That's 7 plus 2. And now I have to divide by 3. And do I have to change the direction of the inequality? No, because I'm dividing by a positive number. So this leaves me x less than or equal to 3. And what this looks like on a number line is this. There's my 0, 1, 2, 3. It would be a filled in circle at 3. And my arrow would have to be pointing to the left because it says less than. And in interval notation, well, remember, our interval always starts on the left and goes to the right. Doesn't matter where the arrow points, its interval goes from left to right. So the end of this interval is the negative infinity because it's going all, that arrow's pointing on and on. That's the beginning of that interval. The end of the interval, the right-hand point is the 3. At the infinity, I put a parentheses, and since the 3 was a filled in, it included, at the 3, I put a bracket. So it's the interval is from negative infinity to 3 with a bracket at the 3 and a parentheses at the negative infinity. Okay, this is where we're going to be stopping today. Okay, we will continue with interval notation and inequalities, etc., on Tuesday. What is your homework for Tuesday? Basic homework is to make sure you know how to access your Blackboard account. You know, you set up a Delta Math account. I may put some problems on Delta Math. If I do, I will post a announcement on Blackboard so that you'll know to look for a homework on Delta Math. But if it's going to be not more than 5 problems. So that's where you should be. Don't forget also, if you don't have a 2-line calculator, try to get a hold of a 2-line calculator over the weekend. Have a nice weekend, and I hope to see you on Tuesday again. Does anybody have any questions before I end class? Okay. I'm going to end the class for everybody. Have a good weekend, everybody.